join us, which is focused on standards. We've also heard about the importance of standards and the process of getting standards in the creation of the Ethernet. And so we want to spend a little time taking a look at where those are today, and in fact how things have evolved. So if we could have. Yeah. So I will, in the interest of the haiku introductions, we have Nan at the end and Metro Ethernet, John D'Ambrosia, 802.3, and I'll also use that for Geoff, 802.3, and for Mai Li, Granite Systems. So with that, I think an interesting place to start is that it took 7 years from the launch of the Ethernet until the actual standard was developed. And one question is today's pace of development, the speed at which we need to develop things. Do we even have time to develop the adequate standards and appropriate standards?
Pick a person.
Go ahead, you're picked.
I'll go. Before we start there, though, I am not 802.11. I am .3, through and through. There are airheads and netheads in 802, and I'm the latter. Moving right along. The 7 or 8 years that Steve talked about, I'm assuming is from invention until the standard was published, although there are a couple other places that you could pick that interval. We made very, very good use of that time. Ethernet was not just an invention which was moved to market as quickly as possible. It was something that was deployed broadly throughout Xerox. We had Xerox's own internet that spanned locations from England to Japan, with altos on it worldwide. And we had an incredible depth of experience with Ethernet as a utility network by the time it was speeded up to 10 meg and introduced to the rest of the world as a product. So the viewpoint that John Schock brought to this microphone when he dealt with some of the issues from IBM about whether these things were important, were firmly, firmly grounded in lots of experience. So I don't think that 7 years is the right number. When we turn something in the standards committee from the start of a project to the time we publish a standard, if we get lucky and the timing is right, the standard comes out very close to when the product comes out. And the reason we do that is because we have the right people in the room, that is, the people who are developing it, when we write the standard. The best assurance of a quality standard is that the actual implementers are writing it while they're doing the implementation. In the instances where we get the timing right, it's about 2 or 2.5 years for that cycle, not 7.
I think 7 years is probably too long, especially in the age of move fast and break things. Okay. I deal mostly with young students. My students are freshmen all the way to graduate and senior at Stanford. And I've been trying to drill that in their head. And I do feel guilty. I do feel guilty because I believe in fundamental research that takes time and takes care. However, you know, the question of whether 7 years is too long, too short, is it the right time? I would like to ask, how many of you in the audience are in your 20s? Raise your hand. Okay, so we have, what, 3 or 4? Now, don't lie, because if you say you're 20 and you're not, I'll say I'm 29, okay? If we want to figure out...
How long have I known you?
the life cycle, the appropriate life cycle of a standard, maybe we should all go ask those people, the upcoming generation. Because don't forget, when we were doing Ethernet, IEEE 802, we were all young totes. We were all in our 20s. And we're probably sitting out thinking, this takes too long.
Those were the days in our 20s, right?
Yep.
Well, I don't think 7 years is a relevant number. And I think when we say do a standard, we're losing sight of the fact of what is Ethernet? What really is Ethernet? I mean, right now, we're doing Ethernet projects that rate from DC to 400 gig. DC to 400 gig.
In a 4,000 page, 6-volume
Yeah,
set.
6 volumes, right. So think
So
about
it's
that.
not one standard.
It's not one standard, it's not one application area. We're all over the place. We're doing all sorts of things, and all of these markets are different, and they have their own needs. Now, what has changed? Well, all of these little smartphones out here. Bob, I quote Metcalfe's law all the time. I love it because it helps my argument in terms of bandwidth. All of these people, you're bandwidth consumers, you're bandwidth creators, you're making my life a living hell because I'm the guy stuck there trying to support it as I go from 100 gig to now 400 gig. And Bob, I know you want terabit. So this is what's happening. And it's not a question of whether, you know, the time to do the standards is too much. It's a question of how fast is the need emerging. Really, it's the need that drives things. And it's not just a standardization effort.
But I think that's my point, is that the needs are evolving faster and faster. And they're coming from these people.
So now, when we start to look at the standards effort, what you need to really understand here is that, and Geoff was talking about we, he wasn't referring to the standards. He was referring to us, the industry. Okay, I say that we do not make, the IEEE does not make decisions. Decisions are made at the IEEE by you.
The standards arena is not a self-sustaining entity. It's a meeting place for the industry. Now, some of the times it looks like it's not that, and some of the time we produce standards that are not relevant. But when we do things that are relevant, it's because we've succeeded as being an appropriate meeting place for the materially interested parties.
And it's a need-driven thing. There are periods and infamous meetings that we can point to, and you remember Geneva, that there was a tremendous industry need at that point in time where everybody came together and drove things fast. We've got projects that have gone from 15, 18 months to years. They're really all over the place, but they're driven by consensus. And that's by the industry. So we have to look at that. And I think the problem, as you're pointing out, is that the need is growing faster. We did a project in the IEEE where we went off and looked at industry bandwidth. And what we're looking at is fabric capacities on average needing to support terabit in 2015, 10 terabit in 2020. That scares you.
Actually, dipping back into history, Steve, there was a 7-year project in 802.3. That was basically a deadlock, and all it succeeded in doing was finally publishing a standard in 3 non-compatible parts and missing the market window.
Yeah, we at MEF, it's a little different from you guys.
Yeah.
You guys are old folks, man.
One, you know, go ahead, Nan.
Well, you know, we obviously
The only reason we can't see your gray hair, man, is because you shave it off.
Yeah. But regardless, obviously we are more, you guys are plumbers from our perspective.
Thank you.
We actually, yeah, absolutely. we're running applications on top of it. You know, Ethernet as a service really is an application we develop. So standards are a lot faster than what you guys do. It typically take about, you know, somewhere between, you know, a year to 18 months. That's kind of our standards. And then we typically do 3 to 4 each year. So it's quite a bit of pace. But some, not to say some of the projects can take a long time because either the support is not there or you know, deadlocked. But we actually made it easier, you know, from the leadership perspective to get the standards through to really help to move the market along.
Do you find, so we heard the story this morning of trembling in front of Ken Olsen as he said, what do you know, why are you giving away my, my technology? So is there an understanding as you work with people that of the value of standards and the willingness to participate and, you know, give up IP in the right way, for, you know, under the right construct? Or is that a struggle that you still have?
I think it's a struggle we have now. I think one of the biggest strengths of Ethernet is that the IP aspect of that was dispensed with at the front end of Ethernet. The fact that Xerox decided to do a fully paid up license on the Ethernet patent set for $1,000 kept the patent wars out of .3 for a number of years, both by that overt act and by that as an example. So the terrible problems we have now with patent issues were actually held off for quite some time by that precedent.
Yeah, and I think the other aspect to this is that the investments that people are making in their IP is becoming more substantial. We're not talking about changing applications and changing software. We're talking about dealing with the laws of physics. And some of the stuff that's being done takes a very good investment. So there's more of a need to protect that investment.
So, and how do we solve that conundrum?
I'm not sure. I think we have our rules in place with the letters of assurance that you'll license it at a reasonable cost, but that's not necessarily protection, and I'm not sure it necessarily helps us. I think if anything, it may in some aspect of deadlock because they don't want to give up because they see the potential if their technology gets selected. So it's a very challenging problem.
So I think it's a very challenging problem from the abstract level of what we would all hope for from a patent system, but also the current situation in the patent system is so dysfunctional that we can't even rise to the level that we all think would be appropriate for handling this.
So, Maya, I really liked your point about, you know, who's the audience for these things, right? And where are they going? And so are there some areas where you see things evolving so rapidly that there aren't standards being developed, but there should be?
Oh God, where do I start? Where do I begin? There's so much. I mean, you know, I love what Radha said about, you know, forget about packet size, forget about flat address or, you know, structural address, forget about all those things. What is it that we want? I want shoes. I wear a size 5 running shoes in women, which nobody makes anymore. So I spend a lot of time looking for shoes, funny enough, Radia. And so to me, that's sort of look at the organic structure of what is it that we need. You know, you talk about the need. The need will drive what it is that we need to do. You know, if a bunch of people decide that they want to find a way to post pictures of their friends on the internet, they did it.
Right.
They did it in, what, a weekend or 2 weekends or something in the dorm.
And there was no call for interest. There was no standard.
No reference, no RC,
yeah.
right? And so I think that there are more and more of those things. Having said that, you know, I still see the need to have the grown-up at the table, to have the gray hair, so to speak, to be there to sort of be the adult supervision, because things are changing so fast. Again, the model of build fast and break things is great until you break things.
Many of the big problems that we have now in technology are systems engineering problems. And the facility that the internet has put into place means that there are lots of communication protocols in existence, so the interchange of information is very good and facilitated, and so lots of development costs have dropped. But getting the level of agreement for solving big problems and taking on the systems engineering aspects of those, which is the element interchange so that you have multi-vendor solutions, are really the area where standards can shine. Probably the easiest example to cite would be smart grid, but there are other problems of that scope and ilk that we really need
That are calling out for
good standards
calling
work,
out
yeah.
for good standards.
Yeah, but I would say that standards are really important, necessary, but I would just kind of gently nudge us into maybe we should think of a new version of it or modified version of it. Take the, I believe, was that Geoff? Was that here? Who's that here in the middle? We're
Glenn.
talking about, Glenn talked about the successful business model is to carry a successful brand forward. So standard, I think, has had is a good brand. We carry forward, but what can we change in the underlying structure so that it will work better?
So on that note, we've seen the advent of open source.
Yep.
And open source, has some of the value proposition of standards, not all of them, right? But it gives you, it removes the monopolistic advantage of the first mover, and so allows people to, manage the fear of lock-in quite differently. It gives some transparency, so you can have white hats probe things. So, is that a way is that a kind of a 21st century aspect of a standard, that we have open source technologies in our application stack?
Well, open source is a good way to get things started, right? So all those people on this panel have done a lot of standards. The standard not necessarily typically down into details. It's really define the actual interfaces among where you can interact with others in a standard way. And not tell you how to design your product or write your code. But open source certainly could evolve in a standard way or speed up the standard development process, but could potentially be, give people advantage, in terms of maybe first mover advantage, things like that. But, is only part of the solution.
So open source can speed time to market and can lower the entry cost for individual entities, but there's no need to write standards down at the line of code level. The standards are for bigger modules for that, where there are conceptual entities that need to communicate with each other.
I don't need open source. I don't need it at the physical layer.
Certainly not at that
Right,
layer.
and- but one aspect-
if where the evolution is
Yes,
happening,
yes.
as my points out, is at much higher in the system.
Yes.
And are we losing some of the benefits of standards, or is that a different way to get some of the benefit?
I would
higher in the stack?
have to defer to the people who are dealing in that space to answer those questions. They're the ones that have to deal with those issues. I think where we're saying is that at the physical layer, it's not an open source issue. It's more going back to the IP issue and the investment in there, which ties back to the fact that what we're doing at the physical layer is providing a stable foundation for everybody, Nan, to do all of the applications and such and services that you want to offer. You still need to have a fundamental, stable ground that's defined by a process which we call standards.
So Nan, maybe talk about for the MEF then, the standards, what are they about? At what layer are they?
We writing on the Ethernet, these guys are obviously pioneered, everybody in the room. So we're really developing, if you would, an Ethernet business model where allow the carriers start selling Ethernet services. And that's really is on top of what the Ethernet pipe has been defined, has been standardized, so allow us to deliver that services. And that service development, what we call a carrier Ethernet. If you think of the Ethernet initially was defined more from their perspectives, more of speed and feed. We kind of gone into a different dimension, which is really about service. Services being offered on Ethernet. Even though we coined it as carrier Ethernet, it's really about the carrier Ethernet services these people can sell and buy, so that you can have an interconnected world with the Ethernet all over.
It's packaging and management. It's productizing the service.
It is. It's productizing the service. We hardly ever deal with actual protocols. Really about how the service is standardized, how the service, how the interface is supposed to be between different carriers. How do you buy and sell services between carriers? How do you offer that services? You're replacing the T1s world where enterprises are asking today. And in fact, I'll just have a really interesting statistics of where last year marked the first year that the aggregate bandwidth of Ethernet services sold worldwide exceeded the combination of all legacy data services. So that's by vertical systems. So it's marking a tremendous progress we made since MEF started. So we really see that trend continue to grow. That gave you a justification to do that at 400 gig.
Right. So at that level, then there is a faster rate that's required.
Oh, absolutely.
Because that services layer is evolving then much faster. So
Yeah.
how do you meet that speed?
Yeah. So we, at MEF, we have multiple methodologies developing standards, and it has a lot of things we do a certification program on, which really enforce the standards we developed very quickly. And also, in addition, at the leadership level, we actually somewhat prioritize the things we wanted to get accomplished, even though it's like IEEE. A lot of members has to be contributing. But if you line up the priorities, things going to get done a lot faster for the things you want to get done. So that's one of the things. The second thing is, we also talked about the certification program, which is MEF has implemented, really helping to enforce that standards be implemented very quickly, and people pick up very quickly.
So let me stop and open it up to the audience, see if we've got any questions.
Okay, so Sean Hackett. I am from an analyst firm, 451 Research, and I'm from the US, obviously. Boston, if you can detect the... So I'm kind of an outsider. I'm not don't really cover the network space. I cover, which I haven't heard yet, and I'm shocked, cloud computing, right? And when we start talking about standards in 7 years, and for me, I'm not 20, I'm at the later half of 30, but for me, things like OpenStack, right? I mean, where we have this loose sort of federation of now, I think it's like 200 companies, right, contributing. Right. 7 years is a lifetime for folks there. I mean, look at where we've come since like 2012, 2010, 11. So for me, I mean, maybe this is a little bit more of a comment, and I think might sort of address this. Things innovate fast, get broken fast, and fixed fast, and this industry at a higher layer isn't waiting for regulations and standards to happen, just innovating, right? And my take when I listen to this, and with all due respect to the innovations that have happened, is those at the higher tier aren't going to wait. I mean, they're not going to wait for standards to happen. They're just going to innovate and somehow develop this. So I guess the question I would have here is, how is that influencing, and maybe other folks here, how is that influencing the network? I mean, how is that influencing at lower tiers, this innovation that's happening at a higher tier?
My answer to that, based on many years of experience, is, and to Steve's opening question, is that at my level, which is a hardware level, and it varies slightly, is the half-life of standards participation is 18 months. And you have to orient everything that you do around how long you can keep people. They have a fixed attention span, which is driven by the nature of their business, and the nature of their funding to participate. And if you can't turn a standard around within the window of participation that you're given by that, you don't have a standards organization.
Well, and the way I kind of answer that is we have actually seen, if you look at all the technologies and with the standards associated with it, they're always pioneers in that particular area where they're actually really developing the prototype or the first mover advantage, so to speak. And then that's lead to the belief that there is a market for it, and that should be the justification for standards. I don't think we need everything need to be standardized. It's just the fact that if they need many people in the industry to be able to develop something and develop that particular market or market big enough, then standard would evolve, as required. And I think it's a lot of the people taking leadership. If you just think about Ethernet, you started, Bob, or even before that, before 3Com, the people already developing the overall Ethernet concept and eventually evolve into Ethernet standards. So I guess my point is that you always have pioneers to go in front of the standards, and then if there's a market for standards, then it happens. So OpenStack is the same way, where people start doing it. If there's a need for the standardization, then standard would actually take care of themselves.
So once again, and this kind of goes to some of the other conversations earlier about why is it taking so long to do things, the problems that we're having, the cross disciplines. Let's remember, we work in an ecosystem. Nan needs hardware. He needs the pipes to run his services. Pipes without services, who needs them? So when we're talking 7 years, we're not talking about 7 years over everything, right? And frankly, I can cite examples that disprove your point about people don't need standards. There are applications and spaces out there where people have waited and insisted on having a standard. But you can't just blindly apply that to every aspect of the Ethernet ecosystem merely because it says Ethernet in it. And we do need to keep that in mind. And that's why that you see things maybe taking a little longer because it's jumping across different spaces. I don't know, when we talk about introducing a service, where do you really say the standard started? Did it start with the beginning of the pipe? Is it just the development of the service that was on top of that pipe? It's one thing building on top of another. And it's just like that with the things that we do. So I'm not doing anything with OpenStack. It's not in my area, but I'm not that person. There is somebody else out there like me who's doing that. They're just not on the panel right now.
Yeah, but that didn't necessarily need standards, right?
Last question, please.
Yeah.
Hi, Pat.
I wanted to make the point that when it took 7 years, we had, is this switched off? I wanted to make the point that when this took 7 years, we had no email. We had no PCs. I'm sure Geoff remembers as well as I do, packing to go to the meeting, making sure we had all the files of all the documents we needed to reference to take with us. It used to take me a few hours to pack documents to go to the meeting with that trade-off of how much it weighed versus how much I needed, and then to put the files back. I mean, one of the things I love about computers is when I take a file out to look at it, I don't have to put it back. It's still there. So, we did this with no laptops, with transparencies, with virtually no email. There was just starting to be some email.
We did it for the first 15 years.
And that made it take longer. It is amazing how much networks and laptops and good email and all that has improved that process. So, when we talk about it taking 2 years or 3 years to do a standard, basically the first few months of that are figuring out that we want to do something and what we need to do. And then it takes about, generally, except in cases where we've got deadlock and political problems, it takes generally, 6 months to a year to get written down really what we want, and the concept's down, and people are well along in implementing. And then the rest of the time is making sure the language is right, making sure it's all consistent and correct, and kind of the last, balloting it, everybody looking through it with a fine-tooth comb and making sure it's clear, because it's that clarity that gets us interoperability and allows the people who weren't in the room to implement as well as the people who were in the room. So really, it's quite
Well,
fast compared to where we started.
I think we should let that be the last comment, and because I believe they're set up for lunch. Is that correct? You want to come up and introduce, or should I just send them off? We can send them off. All right. Thank you to the panel, and lunch awaits.